Okay, in this video we're going to talk about circuits, and we're not going to spend enough time on circuits to really get into them, but I want you to understand the basics, which is really why setting up a voltage will create a current, and why that can help power appliances. Okay, so if you look over here, I've drawn something that I'm going to call as a battery, and so we have a positive side over here and a negative side over here. I then connect the two ends with a wire. You can see this in black going around. And on the wire I've drawn the direction of the current. And so this is just a convention to remember, is that current is the flow of positive charge. So it's going to go from the positive end to the negative end. In reality, the electrons are going to be what's moving in our circuit. So in purple I've drawn the electrons. The electrons will actually be going counterclockwise. So they'll be going from the negative to the positive. And we still call that a current, going from positive to negative. It's just kind of flipped. Don't worry about it. Kind of in the middle of our circuit, right? A circuit is going to be a battery, wire, and then something like a light bulb. I have it connected to a light bulb, which is shining. And I've labeled a point here A and a point here B at the different sides of the battery. And so remember that voltage is a change in electric potential between 2 points. So there's an electric potential at point A and there's electric potential at point B, and the voltage is the difference in electric potential between them. Remember, electric potential is just the potential energy per charge at a certain location. So we're just saying that at a certain location, so electrons at point A have more potential energy than an electron at point B, right? And then there's a voltage there between A and B. Now we can say that the change in electric potential from A to B is this number. And it's that difference in potential energy which drives the current. And you kind of just, I guess intuitively, if we set up all these negatives on this side and all these positives on this side, and we let electrons move, electrons will like be pulled and attracted to the positive end of the battery and repelled from the negative end. So all the electrons in this wire are going to start going towards the positive end because they're connected, right? And so they're going to want to go to the place that will help them lose potential energy. And by doing that, they gain kinetic energy. And that gain in kinetic energy is what's going to power your appliance, like your light bulb. So again, because there's now a potential difference or voltage between A and B, because there's a way for electrons to lose potential energy from going from A to B, the electrons in this wire will tend to flow from A to B, and they'll kind of just move their way along. And again, that's because we've established this electric field by having these charges here, and we've allowed them to go from high potential to low potential through the wire. And then once electrons from this wire start, and they all kind of march in a line, so you can think about it as the electrons are all kind of all marching together and going counterclockwise. Well, eventually the electrons will start to actually get to point B, or get to the positive end of this battery. And then what the battery does, and this is what batteries do, is they use their energy, and usually a battery will have chemical energy stored, and they'll use that energy to move that electron that's gotten there all the way back to where it started. So this electron, which has now lost potential energy, the battery's going to do work on it to make it gain kinetic energy. The battery's going to do work on it to make it gain potential energy back. So now it's at the high potential energy side. And this line here is just showing you that electrons aren't allowed to just cheat and go straight through. So the analogy I'll use is of a water wheel. So if we have a reservoir up here, there's high potential energy at point A and low potential energy at point B. The water will naturally go from A to B, but in doing so it will gain kinetic energy. That kinetic energy is going to be used to change or to move this water wheel, which is our light bulb. But then the water now has low potential energy. What you have to do to maintain that potential difference is to pump the water from low back up to high so that you still have water in the reservoir to move the water wheel. And try to think about it in gravitational potential energy terms if the electric potential energy is not intuitive for you. And that's the circuit in simplified form.